today's lecture is about prototype pollution. So when I'm talking about prototype pollution, I'm talking about the web vulnerability that affects JavaScript prototypes. Um, but before we even dive into how the vulnerability works, we need to understand four key concepts. So we need to know what JavaScript objects are, JavaScript classes, JavaScript prototypes, and the differences between classes and prototypes, and also inheritance and how that behavior works in JavaScript. Okay, so JavaScript objects they're like containers that can hold different pieces of information. So I'm sure for all of you here, you're quite familiar with the JavaScript object notation or JSON files. So all JavaScript objects have the same type of syntax. You use key value pairs within curly braces, and you can hold different types of data in JavaScript objects. For example, in my example here, if I call console.log person.name, I should get my name out. Okay, JavaScript classes are like blueprints, and they allow you to help create multiple objects with similar structures and behaviors. They are a very convenient way to instantiate instances of certain objects that have the same properties. And if you have done, for example, Java or C++, which are object-oriented programming languages, you will see a lot of the same features being used to facilitate object-oriented paradigms, things like encapsulation, polymorphism. So JavaScript has all of that under the hood as well. But what's the difference then? So we've got classes and we have prototypes. In JavaScript, every object that exists has its own prototype. So every object is linked to a prototype object. These prototypes form a chain, which is known as the prototype chain, and they serve as a template for objects. And whenever you, for example, create an object or instance of an object, JavaScript will automatically link the object and its prototype together. So in the example I have here, I have defined a user with two different properties in a function. And if you look at the prototype, you can see that it's got the name, age, and greet, which is the function. But you might be asking, well, we have classes and we have prototypes, and they kind of are targeting the same functionality in JavaScript. So what's the main difference? Oh yeah, so before I get onto that, I have expanded the example here, and you can see that I've created a regular user at the bottom with the prototype of, so what you can see here, the middle function there is a constructor function, and inside the constructor function, I've created an object using the user prototype, and that user prototype has a function called greet, but I can actually access the greet function directly on the regular user object because the function has been inherited through prototypes, the prototype chain. I will get into a bit more detail of how that works. So what are classes versus prototypes? TryHackMe has a really good analogy here, and it says that classes are more akin to like using a blueprint to manufacture the exact same object each time. So classes are very structured pieces of code. You can define things that are supposed to be applied across all objects, and you can set very strict, for example, parent and child classes where you want defined inheritance to happen. So in this context, or in this analogy, I've used car factories. For classes, you have a very detailed blueprint of a car that you want to build, and you basically use your classes to keep creating a bunch of these cars, but they all have the same specification, the same properties, the same design. Prototypes are slightly different. In this case, it would be more like you start with a model or a chassis of a car, but all of the different pieces that you add onto it, like the wheels, the dash, the windows, and the tires, they are all completely different and customized by you. So you can use prototypes to sort of like dynamically change the properties of your object. So in the example here, for classes, the typical use case is I'm assigning a bunch of users with the same type of properties. But with prototypes, what I can do is actually I can add on properties to an object by using it as its prototype. So you can see here that I have a blogger with all of these properties attached to that object, but it uses content creator and user as its prototype. So if you follow it up the chain, you can see that there's inheritance behavior. And I'll go into more detail in the next slide. So JavaScript inheritance, if we go back to the example that I had just now, you can see here that the content creator profile has its own unique properties, such as content and post. So you see at the bottom here, you've got engaging content and post is set to 50. But you can also access the properties of name, age, and followers directly on the content creator profile object because it's being inherited from the user prototype. So this is what I mean, is in this code, you've got content creator profile, which is technically its own object. But because the user is a prototype of that object, it also inherits all of the properties. And we will see how this is really useful when it comes to going up and down the prototype chain. Yeah, so you can see here that if I'm looking for the age property in content creator profile, what JavaScript does is that it looks in content creator profile and it sees that the property doesn't exist there. So it goes up the prototype chain to find the property in user, and that's where it sees that, oh, the age property comes from the user prototype, and that's how it returns the value 25. Okay, so when we want to access properties, for example, content creator in this diagram, the property doesn't exist in the object directly. It will look up the prototype chain for that property, which is why I explained just now. And this allows us to extend objects dynamically with inheritance. Okay, so now that we have covered the 4 concepts I've showed earlier, we can have a look at what the prototype pollution vulnerability is and what it does. So let's have a look at this JavaScript code. So this JavaScript code is, for example, for a social media website. And we have a person prototype, which provides an introduce function. And we use an instance of a person object, which uses person prototype as its prototype. So inside person prototype, you see an introduce property, which is a function, and it returns, hi, I'm this.name. So if you think about a social media website, you log in and your name is, for example, John, you will see a value being returned, hi, I'm John, something like that. And how can I call this function, for example, in the JavaScript console, considering I made a person with the name Ben? I can do console.log ben.introduce. Which are missing. Yes, it is missing actually. I was also supposed to hide that prompt and ask you guys, but yeah. So prototype pollution works because an attacker might try to inject malicious content into the introduce method using the proto property. So the double underscore proto property is an inbuilt JavaScript property that you can actually use to access an object's prototype in real time. And the interesting thing about JavaScript is that all of the classes and I guess the prototype functionality that they use, it's not static at all. So if you make changes to an object's prototype, it will recognize that its property has changed in real time. Whereas, for example, in Java, usually when you set a class, you can't dynamically at runtime change the underlying class structure while you are using the code. But this is possible in JavaScript, and this is what allows the prototype pollution vulnerability to happen. So what happens here is an attacker will try to use the proto property to change the introduce function. So instead of returning, hi, I'm this name, it says, you've been hacked, I'm Bob. And if I run console.log ben.introduce after that, what I will get is the string that's shown there. So you've been hacked, I'm Bob. And when this happens, for example, when a prototype for the object is polluted, it affects every instance of the person prototype, including existing ones. So let's say I have 4 people here, which all so all of these objects has person prototype as its prototype. What will happen is if I change the introduce function using the proto property, when I look at all of these people objects, they will all say you've been hacked, I'm Bob. So even though the attacker used the Ben object to change the introduce function in the prototype, it will affect every instance of objects that use the person prototype. So typically, the proto and constructor keywords are used as targets for exploitation, and usually prototype pollution vulnerabilities, they have this kind of structure where if a property is defined using paths, for example, like object in A, B, and C is equal to a value, it's really dangerous if the attacker has control to some of those parameters. So one example I can put here is, let's say I assign a property of person using person x and y equals to value. If, let's say, an attacker has influence over the value of x and the value of val, what they could do is they could change the prototype of the person and assign a new property called y to value. Does that make any sense?
Why is the word property? Like at the very beginning, it's x and y.
Okay, so here x and y are supposed to be like variables, right? So you might be passing in like person's like name and then like last name for x and y to try and access like a nested property. Does that make sense? But what happens here is that because you've input proto instead of like a variable, which is supposed to be used to access the object, it refers instead of to the person object to the prototype of that person object. Does that make sense?
Kind of. I think so.
Okay. We'll get into examples as well, so it will be a bit clearer. So the first example I have here is a cross-site scripting exploit. So usually prototype pollution by itself doesn't necessarily mean that your website is vulnerable, that the fact that prototype pollution is possible. But prototype pollution combined with bad code and, for example, lack of user input sanitization, it can lead to things like RCE as well. So let's say I have a website where you can view your friends, and the friends array contains friend objects where all the properties are displayed on the website. So I have here like friend with the ID 1, and I've got the name and the age and the country that they're from, and for example, different things that will appear on the website. The website uses the -set function, well, the _set function in Lodash. So Lodash is a utility in JavaScript, which is used to manipulate like arrays, objects, and strings. And it's used to modify the friends array by passing in an input path and input value. So if you look back to the example from last slide, you know, the path of attack here is if an attacker can control x and val, which is if they can control the path to the object and also the value which would be assigned to it. The example here is showing how that looks in practice. So the code on the server side says like if they want to set a value in the friends array, they would set the friend, which is passing in like the ID, and the input path, so that could be like age, and then the value would be like 30. Is that clear? Okay. So this is what it looks like on the website. So what you can see here is that I'm looking at a friend and her name is Sabalenka, and on TryHackMe, this looks more like a debug view where you can actually see all of the properties are in the friend object in the friends array. But there are a few functions on the website which I can use. For example, I can submit a review. And if I submit the review, what will happen is that the string that I passed in will be sent as like a post request to the server side. And that value gets passed in to the set function. And what will happen is that the review that I sent will appear on the website.
Where the server side is running JavaScript, server side.
So the server side, yes, the server side's running JavaScript because it's a Node.js backend.
So this would work on a PHP. So
No, it wouldn't work on a PHP website.
Surely if it's just the data, it's just like if anyone else tries to load that same data, because the front end will always be in JavaScript, if they load the malicious data, then they've got it on their machine, which is also malicious.
that's what I thought. But so it sounds like this is an exploit which is actually executed on the CPU of the server, not the client.
Yes, this one is on the server side. So here's the thing. If, for example, this was run on the client side and you were trying to set the array, it wouldn't be any different from you just manually changing the values yourself.
Like just going into dev tools.
Yeah.
It would only affect your
But of course, because this is using a Node.js backend, what's happening is that when you make changes by the function I showed you before, it will reflect on everyone who views that page. So if your question was, is this using a JavaScript backend? Yes, this is using JavaScript backend.
Oh, JavaScript and backend should not go together. Horrible.
It does sound really weird when you say JavaScript and backend.
Oh, no.
But yeah, so let's say, so what I wrote over here looks like this. That's the sort of payload I'm sending. But let's say an attacker thinks, well, instead of sending that, I could probably send JavaScript lock to the backend, and let's see how that works, right? So this is what the friends array would look like if I pass in this payload. Essentially, I'm going into the friends array, into this object, and then in the reviews, what happens is that the payload will look at reviews and the first item in reviews, and then it will set that property to be script alert any content.
So what is the point of this lodash.set? Why not just type friend dot or at reviews at nodes dot content equals? Validation stuff?
So the reason why is because if you think about it, for example, if I wasn't just setting reviews, I was trying to set multiple different
Fields.
fields at once. And let's say,
You couldn't do it from one set call, could you? How would that look like?
well, it just makes it easier to enumerate. For example, let's say you have a post request that you are expecting from the client and they want to change multiple fields at once. What you can do really easily with Lodash is you just parse the JSON and then you pass all of the paths that have been given to you in the JSON directly. So you can use like a for loop, like for dash in path, put in.
Okay, so for the second parameter to lodash.set, you can pass in an array of paths as distinct from just a single path.
What I meant was if you, for example, use the for loop to enumerate through all the paths that have been sent to you as an object, what you could do is call _.set multiple times, but it would be a lot easier than manually saying, okay, take the first element and then set this to that. And I guess what Lodash also gives you is that if it doesn't exist, it has the proper like handling,
I see.
whereas you will get an error if you try to set something that doesn't exist.
Can read something on multiple paths.
Yeah. I'm not very sure because I haven't used Lodash before, and obviously I've never worked with JavaScript-based backend. I've always used like either Python or PHP. Yes.
How many tenants do you want? Is there a way?
There might be an X powered by HTTP header, but
Yeah, something like that.
Test it. If it doesn't work, it doesn't work. If it does work, you're nice one. Alright.
You could also kind of tell from certain like errors in the backend, but I don't. Yeah, I think the HTTP headers is the best clue that you can get like from just like any given client. I don't actually know because there's no like
if it's horrendously slow, you know it's JavaScript.
Potentially, yeah, potentially.
Really,
I guess well, the thing is like, because if you think from the front end, no matter what backend you use, you can always serialize things into like JavaScript object notation. So you may not really know if, for example, they obscure all headers, you might not really know what backend they're using. You can only tell if you know all the backends well and what their behavior is like from different languages and different frameworks. Okay, so now I'm a hacker, so I've tried to use that payload, and if you guess what might happen, you get hello world. That payload doesn't actually match, I just realized, but essentially it proves that cross-site scripting is possible. So what happens here is that I was able to set the reviews property of the friend object by using the -set function from Lodash. So by passing in the JavaScript block in the payload, whoever visits Sabalenka's page will run the JavaScript block. So that proves that a cross-site scripting exploit is possible. So here's the actual code of what happens in the backend. So the server-side code accepts a post request to the endpoint submit friend review. And if you look at the code closely over here, where it says const input equals JSON parse review content, that's what I was referring to earlier, is that it makes it really easy because you just parse in all of the content that is being given from the front end. So rather than needing like an enum in the background that checks for, does this property exist or not, you just put in the path that you want to change and also the value that you want to change, and that will change the JavaScript object in the background. Okay, so if we have a look at Burp Suite to look at what the post request looks like, you can see here that there is actually a hidden friend ID parameter, and we can also use that to target different object properties. So if, for example, you have multiple friends with different IDs, you could also use Burp Suite to intercept the request, change the payload that you want to send, and you could also use this cross-site scripting exploit on multiple friends that you have. Okay, yeah. So the second one is property injection. Oh, yes.
If instead of having a dynamically sized string, you just had an array of characters, wouldn't that mean that this doesn't be safe from any injection? As an array of characters, you know it's going to be a certain length. And so you can just treat the certain length as string no matter what.
I'm not sure I quite understand what you mean by that.
Because the reason why these things fails, because the scripts always look like an end tag in the string.
Yeah.
Usually, and then they just put some code after the end tag. So surely you could just say, well, we know that there's going to be exactly 65 characters of just string, so treat the next 65 characters as a string.
So you are right about that, but we are looking at the very naive case here where you don't have any validation at all from the input. Does that make sense?
Okay, yeah.
That, to be fair, it is true, because if you think about any sort of basic input sanitization, you can strip out essentially anything that's dangerous from the backend. So it could be JavaScript tags. It could even be the keywords that they're targeting in the first place.
I feel like when you can sanitize it, you just say, treat this block of characters as a string no matter what.
There are also like content security policy headers that you could also set, and you could control essentially what goes into your requests. So that's also a way to mitigate these kinds of like exploits. But yeah, we're looking at a case of how prototype pollution might happen, obviously in a very naive case where a developer doesn't care at all about doing any sort of input validation or sanitization. Okay, so the second exploit I want to show is something called property injection. This one would probably be the most common form of how prototype pollution occurs. So sometimes in the backend, there is a function called the object recursive merge. So if you look at the function over here, what you see is that it takes a source object and a target object, and then it merges all the properties from the source into the target. Does it make sense? But if the merge function doesn't validate inputs and the attacker somehow manages to, for example, the source object was passed in from a post request, it could allow attackers to merge properties into the prototype chain. And what you can see here is that, for example, if an hacker sends a request with a nested object containing proto with new property is equal to value, what might happen is you have, for example, in the code I showed earlier, the intended use case would be I have settings, and then I have an input payload that I send through like a post request, and I would expect to update the property in settings from, for example, dark to light. But if there's no like input validation, what could happen is the attacker might try to put in the prototype keyword and then say, please assign a new property to value inside the prototype linked to the settings object. And what happens here is that you will see now in settings, it will be reflected across every call to the settings object. There will be a new property named new property with the value. Okay, so now we're going to look back at the social media website example that I showed earlier. So we can see here that there is an endpoint which is called clone album of friend ID. So this is like an endpoint that allows me to look at a friend that I have and clone one of their photo albums, something like that. And inside that endpoint, you can see that at the second last line, you've got merged clone album and payload. So what the endpoint is trying to do is it takes in a payload, which is supposed to be a new album title. And it's saying, clone the album from your friend to a new object, and then merge in the new album name that you want to name that album. So you can see here that I copy the existing album into a new object, and then I merge the payload and the cloned object's properties. Okay, so this is what it looks like on the front end. So I have the option to select an album that belongs to Sabalenka, and I want to usually I could set a new album name and then I would copy it into my own profile. But what the attacker is doing here is that they're sending the payload that I showed you just now, and after sending this request, what will happen is you'll get this push request sending it to that endpoint, and then you'll see the new property shows up in the friends array in that object as well. And because this property injection has merged in this property into the prototype, this will affect all objects that refer or use this prototype. So if I look at a different friend, for example, I look at Lara's page, you'll see that I also have the new property hacked in the object because the prototype is successfully polluted. So all instances of friend will contain a new property that was maliciously injected.
And that would be true for only as long as for the lifetime of the node process on the server.
Yes.
Like stored in the database.
So if, for example, you cause the node server to crash and it restarts, then that property will be removed after that, because obviously from the static code you didn't have all of those properties defined before. Does that make sense?
Right.
Yeah.
Next time we run it, it starts.
Yeah. Okay. So the third type of attack would be a denial of service. If an attacker can manipulate the prototype of a widely used object. So if you think in the backend, like what are some really popular JavaScript functions? It could be things like toString, toUpper, toLower, like string manipulation functions. It could be like common math functions in JavaScript. If an attacker can actually manipulate the prototype linked to that function, it can actually cause the application to behave really unexpectedly or crash. So let's say, for example, an attacker pollutes the object.prototype.toString method, and a lot of websites use the toString method to convert a data type from something that's not string to string. Every subsequent call to this method will execute the altered behavior. So let's say I changed the toString to do nothing. So it's not a function anymore. It's been changed to a string. Then yeah, I get a whole bunch of errors across the website because it's saying that I don't know what to do when I call toString because I get just the value, a string value back. It means that you've successfully polluted the prototype of that function and caused the website to not function anymore. So a polluted method can lead to inefficient processing or an infinite loop, and this can cause the application to exhaust system resources and cause the denial of service condition. It can trigger unhandled exceptions on errors or interfere with application logic. I don't know why I repeated that twice. So now you can see here, I have a payload that's trying to override the toString function to just crash the server. And I'm using the same endpoint again. And if I click clone album, this is what happens. The website kind of crashes. It becomes this, it gives me this error message that says object.prototype.toString.call is not a function. It means that it's trying to call the function, but it realizes that, it's a string. It's not a function that it expects. And this does create a denial of service condition. So until I restart the node server, it will stay in this condition whenever I visit the website. So yeah, it says causing a recall to return an error. And so here are other built-in objects and functions that you can try and override. So things like toJSON, value of, and constructor. But depending on which function you choose to override, it doesn't necessarily mean the application will crash. The behavior entirely depends on the function that you are overriding. Okay, so now talking from the perspective of, you're a cybersecurity professional, if you're a pen tester or developer, how can you identify prototype pollution? It is not straightforward. It's not as easy as other common website security problems. Because each web application is different, you can only figure out if prototype pollution is possible by looking really closely at the website's code. So TryHackMe has also linked several prototype pollution sort of static code analysis scanners and also fuzzers. So one way that you can kind of detect if prototype pollution might be a vulnerability in your web application is you can use these fuzzers where they would try a whole bunch of like prototype object combinations to try and figure out if your prototype or your web application is subject to prototype pollution. Is that clear? Okay, so for pen testers, what are the mitigation strategies you can do to try and prevent or to identify if prototype pollution is a problem for your web application? Like I said earlier, you can try input fuzzing and manipulation. If you fuzz your user inputs, and especially those used to interact with prototype-based structures, you may be able to catch, for example, generic versions of prototype pollution. So ones that are probably using like word lists and common overridden functions. But it's not a catch-all feature, so it is not necessarily enough to catch every possible instance of prototype pollution. So what you will need to do is to manually analyze the application code base. You should look at the functions in your backend carefully to try and see where user input might be used to access or interact with an object's prototype. You can try and use static code analysis tools. So a lot of cybersecurity software companies, they do provide these SAST tools, which you can look at your backend code and try and see if there's potential prototype pollution vulnerabilities. You can test for content security policy bypasses or payload injections. And I guess the most important part is if you use any third-party dependencies, you do need to check if they're up to date or if they are subject to prototype pollution. Not dependencies, I meant prototype pollution attacks. I wrote that wrong. Okay, so for developers, you have a few strategies which you can use to avoid prototype pollution. In your code, avoid using the proto keyword. You can use the function getPrototypeOf instead to get the prototype of an object. And you can try and use immutable objects. So what this means is you can create an object in JavaScript, and then you use the object.freeze function to try and make it immutable so that you can't change the properties in runtime. You can also use encapsulation, so you can make methods and fields private by prefixing them with the hashtag. This allows you to prevent public access to certain methods and fields if they're not necessary. You can use safe defaults. So if you set predetermined defaults beforehand, you can avoid the case where an attacker might have access to doing a prototype pollution attack based on path-defined properties, which is what I showed earlier in the slides where you've got person xy equals val, and use input sanitization. Okay, so these are the resources that I've linked to where you can look at the prototype pollution attacks and the descriptions of how it happens. I've linked a video here that does go through a run through and also shows you an example of how prototype pollution attack might happen to gain like access on the server side.